Okay, so here's the deal. I've got a bit of a makeshift setup here. By the way, that might be a word on the GRE, or at least it is according to the flashcards that I spent $40 on. So, I wanted to do a Khan Academy style video. That didn't end up working out because I can't afford that little pad thing that I use to draw on. But I do have a chalkboard, so here we go. Let's learn about some math. We have y equals x to the power of 106 minus x to the power of 100. What are the prime factors of y? And just in case, I'm actually left-handed, and just in case you need a review of prime factors, maybe I can just show it by example. That'd be the fastest way. So we have the number 63. 63 is 9 times 7. 9 is 3 times 3, sorry. So the prime factors of, the prime factors of 63 are going to be 9 times 7 times 3 times 3. It's worth noting that this is different from distinct prime factors, and this could be on the GRE. So the distinct prime factors of 63 are 3 and 7. The prime factors of 63 are 3 and 7. So there's a big difference between the two. Easy to get them mixed up. Just, I don't know, just watch out for that. So we're wanting to know the prime factors of this. And so, how the heck do we solve this problem? Why, thank you for asking. So, as you'll recall, if we have x to the power of a plus b, that is going to be equal to x to the power of a times x to the power of b. Okay, so we have x to the power of 106. That's 100 plus 6, a plus b. Okay, so it's x to the power of 100 times x to the power of 6, right? Okay, so we got that. So now what we have is y is going to be equal to x to the power of 100 times x to the power of 6. Did that? Okay. Put that in parentheses. Minus x to the power of 100. As you can see, this problem is actually remarkably simple once we figure it out. All we have to do is factor out x to the power of 100. So now we have y. Y is going to be equal to x to the power of 100 times x to the power of 6 minus 1. These are our prime factors. We have x to the power of 100 times whatever this is, x to the power of 6 minus 1. Now, that's not a very satisfying answer. And if this was actually a GRE problem, you might even see an option that says cannot be determined, right? And so, because we don't know what x is, it can't be determined, but what we can do is we can say what would happen if x equals 2. Put that right here. Hopefully, you guys can see that. It's kind of towards the bottom of the screen. I'm going to rewrite this problem with x equals 2. And so if you have, what am I saying? Okay, if you come across on the problem of the GRE, I cannot speak today. Anyways, so if you see this problem on the GRE, 2 to the power of 106 minus 2 to the power of 100, maybe it'll ask you what the prime factors are, what the distinct prime factors are, what the greatest prime factor is, whatever. It can all be done just with this right here, the equation that that I just proved right now. So just plug x in for 2. So we have 2 to the power of 100 times 2 to the power of 6 minus 1. Okay, what is 2 to the power of 6? It's 64. That should be memorized, but we'll do this instead. 2, 4, 8, 16, 32, 64, 1, 2, 3, 4, 5, 6. 2 to the power of 6 is 64. 64 minus 1, oops, that is 60, crap. That is 63. Okay. So, the prime factors of this thing right here, that's going to be 2 to the power of 100. So 100 of 2's. Okay. And then a 63. Now, I already showed you guys what the prime factors of 63 are. In the beginning of this video, I chose that number on purpose. It's going to be 3, 3, 7. Yeah. So if the GRE asks you what the greatest prime number is, it's 7. If it asks you what the most common prime number is, it's going to be 2. If it asks you how many prime numbers there are, how many distinct prime numbers there are, it's 3. It'd be 2, 3, and 7. Those are the distinct prime numbers. I don't know if you guys can see that. Good enough. So yeah, that's how you solve the problem. We did it. Okay. Yeah. Have a great rest of your day.